So whenever you square the both sides of an equation or raising the both sides to the even power, you always need to check the solution, okay? Check the proposed solution. Now, let's check these two special solutions, okay? One is the pi over 3, another one is 2 pi over 3. And let's first check the pi over 3. So let's plug in the pi over 3 into this left side. Then, okay, now let's check pi over 3. So plugging this pi over 3 into the left side, we have the cosecant pi over 3 minus the root of 3. And we know cosecant pi over 3 is equal to 1 over the sine of the pi over 3. And this is equal to 1 over the root of 3 over 2, right? So let's flip this 2 to the top. Then we have the, okay, let me write the minus the root of 3 minus the root of 3. Okay, we still need to copy this part. So we have the 2 over the root of 3 minus root of 3. And then let's rationalize the first part. So you have the 2 times root of 3. So you multiply both the numerator and denominator by root of 3. So you have 2 times root of 3. And then denominator, which is the square of the root of 3. So that is equal to 3. So you have the 2 times root of 3 over 3 minus root of 3. And this is equal to the negative root of 3 over 3, right? You see you have the 2/3 minus 1, you have the negative 1/3. And negative 1/3 times root of 3, you have the negative root of 3 over 3. So this is the left side. Now, let's look at the right side. The right side is the cotangent of the pi over 3. Let me move to the next page. So the right side is the cotangent pi over 3. And we know cotangent of the pi over 3 is equal to what? Root of 3 over 3. Okay, you must memorize all those track function values of the most common used angles. So definitely you compare this one with this one. This is negative root of 3 over 3. This is left side, and the right side is the root of 3 over 3. So negative root of 3 over 3 is not equal to root of 3 over 3. So that means this pi over 3 is an extraneous root. So we just discard it. And then you can verify, okay, you can continue to verify this 2 pi over 3 is really the solution to this equation. So in this way, we form the general solution to this equation. So the solution set S is equal to the set of X such that X is equal to 2 pi over 3 plus 2k pi, and then done. Okay, let me show you one more complicated example about the tri-equation. So let's go to the page 567 And let's look at the 76. And we have such equation 2 times cosine square of 2x minus 8 sine square x times cosine square x equal to -1. So this is an equation involving the multiple of x, right? I have 2x here. And this equation involves the sine, cosine, okay, these two, okay, trig functions. So we want to convert this equation into one equation which involves only one trig function and only involves the variable x, not the multiple of x. So we have to use some identities. So first, let's look at this cosine square of 2x. We know this double x, right? We can use the double angle identity for cosine. We have the cosine 2x equal to 1 minus 2 times sine square x. Okay? So in this way, we can replace this cosine 2x by 1 minus the 2 times sine square x. And then for another, okay, cosine square x, we can use the fundamental identity. So that is a cosine square x equal to 1 minus sine square x. So now, let's do this substitution. So the original equation becomes 2 times square of the 2 minus the sine square x minus 8 sine square x and times 1 minus sine square x equal to -1. Now let's try to expand the left side. So we have the 2 times 1 minus, okay, 2 times 2, you have 4 sine square x and plus 4 times sine to 4th and then minus 8 sine square x and plus 8 times sine to 4th equal to -1. Okay. Then let's simplify. So here we have another, okay, right parenthesis. Okay. So 2 times 4, you have 8. So 8 times sine to 4th plus the 8 times sine to 4th, you have the 16 times sine to 4th. And here we have the 2 times -4 sine square x. You have the -8 sine square x. And you have another -8 sine square x. So you add that, you get -16 sine square x. And for the constant, you have the 2 times 1, you have 2, and then plus the 1, you move this -1 to the left side, you got the positive 1. So 2 plus 1, you have 3. So now, we have the one equation of the quadratical type. And I say this equation is of the quadratic type because we can do the substitution to change this to a quadratic function.